Hello, welcome to Mix Training. This is Varomix, and today we're gonna do a rain of arrows. Alright, so like I said, this is the final scene. You can see we have a lot of arrows that are gonna be flying. You already saw at the start the animation for this. It looks pretty cool, and this is something that you might be done in a project, so it's pretty popular stuff to do. And we're gonna use particles for this, believe it or not. So I'm gonna go for a few parts. I'm gonna skip, and I'm gonna show you the animation and the particles part, because creating the terrain and stuff, it's not important for this, but I'm gonna just walk you through that. So this is the final scene, which you can get if you go to our Patreon page, Mix Training. And you can get all our zip files from this and other projects there. Okay, so the terrain is pretty simple. I just created this height field here. You can see it's just a huge height field. I added some noise to it. You can see the parameters here if you want to copy whatever. And again, if you want the file, you can get it from our Patreon page. You can go, and then I just clipped this to create like this flat hills here. I'm gonna be shooting from here to there, and then I just added some extra noise on top of that. You can see just a little bit of extra noise, which is it's not even that noticeable. Then I created this erode node here, which is just you just create that, and then the trick here to look like that is going to the visualization here and compute the range. So it detects your tops and your low areas, and then just start the simulation, and you can see it starts creating this rivers areas and eroding the terrain. And this is a little bit heavy. I made it a little bit too heavy for my taste, or for what this was, but it's alright. It's calculating pretty quickly. You can see you can stop at any time. Stop. And you have your terrain eroded. You can see there's a lot of stuff there, rivers, water there accumulating, all that stuff. Then after that, I just converted this to polygons using the convert node, and just use it in the scene, because right now up to here it's a volume representation of the terrain. So you can see it's polygonizing this. It takes a little bit to do it, but once it's done, it's just a polygon surface, so you just can do whatever you want with this. Now you can see there's a lot of polygons here. There's some stuff here extra. I don't know what this is, maybe the rivers or whatever, but I just deleted a few things here. I just selected the geometry that was connected to this, and that's what I kept. Deleted everything else, and that's my terrain. I just saved it to file. You can see I have it here. I clean up the attributes, so you didn't have like all the attributes it has by default, and just added some UV texturing, projecting from the top, just to give it some texturing. You can see just testing with the texture there, and see what's doing. So that's the terrain. It's pretty simple stuff to do. Maybe we should be doing a terrain class someday. So let's not see that stuff in the terrain. Just go to the UVs here. There. So now the other part is the arrow simulation. And the arrow simulation we're going to be doing ourselves here, which, as you can see, it's pretty simple stuff. It's not that complex. So let's go to let's create a new node here. Let me save this scene as another file. Save as Renovirus tutorial, and let's create a new geometry node here, and let's call this arrows sim 2. Alright, so let's go there. So we're gonna import the terrain first. The file that we imported. Let me just copy some notes here. You can see I have the terrain again, and I have the node that it's cleaning up. The attributes. Then I have some other nodes. Let me just, it's just simple stuff, so I don't want to bore you with this. So I'm just selecting an area over here where I'm gonna emit the attributes from. You can put some geometry here if you want and not use this, but I wanted to use the terrain just because it's in the spot that it should be. So I just did that, enable the bounding box, move the box there, just like this, put it there. Then I just create an attribute there for those points and call it emission. You can see I'm selecting the group that I created here. I'm adding this attribute called emission to that. So now I'm going to the popnet with that attribute. This might be over the top. I could, maybe the best way will be here to just delete everything so we don't pass all this geometry to pops. So let's do that. There we go. We have that. Now let's create a pop network. And now we're gonna go inside. You can see we already emitting for that. If we are deleting this, we don't need this emission attribute because it's still gonna emit from that. But if you just want to emit from an area, you can use the emit attribute. I'm gonna show you how to use it. So inside here, you can go here to the source, and there's an emission attribute here, and you can select the attribute there. It might be a little bit out of your. Let me turn these guys over. Here in the emission attribute, it is you can select your attribute. It doesn't have, it's not, it doesn't have to be name emission, but it just makes it easier for me to know which attribute I'm using for that. And you can use it there. Let's use it. Let's use it there. We're still gonna emit just from there because we deleted everything else. So now we're gonna use, we're gonna connect another geometry to this. So I'm gonna import some other geometry that I prepare for collisions, which is this one. And this one is just the same terrain I created, but I just reduce it with the poly reduce to 10%. You can see, we can see that here. It takes a while, but here it is. What I did is I just poly reduce this. See, it's trying to do it, but it's gonna take a while, so we're not gonna wait for that. And then I just clipped a piece of it, and the result is what we have here. Then I just saved it to this, so we don't have to calculate that stuff again. And the result is this. It's just the area where the arrow is gonna fall. You can see this is the full geometry, and this is just a part of it, so we don't have to calculate all those points for collisions. That's why I did that. So if you have the file, you can see what I did there. So I'm going to plug this into the second input because this was going to be used as the collision geometry. So let's go inside here and let's put a poly, not a poly, a pop collision detect, and we're gonna use that. We're gonna use the second input, which is the input and it's not deforming. We don't want to do that. And we're gonna put this in the behavior. We're gonna create a group for this, and let's call it hit group. So we know which particles hit the geometry. All right, so the response is going to be stopped, so we don't want the particles to move after that. And compute heat total is not necessary because they're going to stop, so we don't need that. Now we need some velocity for the particles, because right now if we play, they are not moving and there's a lot of emission there, so we just want to emit for a few frames. I'm going to use the impulse activation. I'm going to emit, let's say, just for the first 5 frames for now. I'm gonna emit 20 particles each frame. You can see I have those particles. I'm gonna have like 100 at the end, 80 because it's 5. Let's put it to 6 to have like 100 particles there. Now we need some forces because these guys are not moving. So let's set the initial force here. Let's put 50 on the Y, so it's go up. 50 on Z because we're gonna push them in this direction. You can see this is the Z axis. And let's put some variance so they don't go just linearly. So move a little bit. Even in X, we need them to kind of spread a little bit. So there you go. You can see they're going up like that. And the distance is here, it's really far away. So we're making like a really world scale kind of a distance here. So they're pretty far. Alright, so I got this. So what I did is I just kept the original values. 50, 50, and 3, 5, 3. This is what I use for my version. So I just went here to the pop solver and put the time scale to 4, and that just makes it 4 times faster. So now it gets faster there, and we can keep on going with this tutorial without waiting so much on those particles to get there. Right? But you can see now they are colliding with the terrain that we set, and they turn red, and we know that those are the points that we want to when we want the arrows to get to. Okay, so now what we're gonna do is spin these particles because we want to put some geometry into there. And so let's see what we're gonna do for this. How are we gonna copy those arrows to the geometry? And I'm gonna copy again. I'm gonna use the arrow geometry I already have here, which is, you can see this is what I model here. It's an arrow. There we go. It's just model here in Houdini. It's really simple geometry. It's alright. It's gonna be instanced a lot, so I didn't make it so so complex, but it has a texture and it has UVs and all the stuff. You can see there's the UVs and has a little texture for it and works really nice. Alright, so that geometry, I'm gonna be importing it here. You can see here I just import the geometry with this nodes. So let's just put those nodes here because we don't want to lose time with that. You can see the geometry is there. I'm just moving it here. This is the stamp position, and this is the rotation, but these guys are gonna be used later. So let's put a copy stamp node. Copy stamp node. Again, if you want to use the copy to points node, you can use that one. I'm gonna use the copy stamp node. Now you can see we are already copying arrows to those points at the start, and you can see they go away, but they are in the wrong direction. You can see they are not correct, right? So that's why I did this nodes. This is just rotating the node, but we're missing the expression. And what we are using for this, let's go to the stamp. I create a rod parameter, and I just say random $ID, which each arrow has an ID attribute by times 360. So this is pretty simple stuff. Don't be afraid of this. This is just a random expression that randomizes by the ID attribute. So each arrow is going to have a different direction, and then it just since the random attribute expression gives us value from 0 to 1, I just multiply that by 360, so we have values from 0 to 360. So now this guy is going to rotate them in that direction. You can see here, stamp the input, sorry. Now each arrow is going to be rotated differently, so they aren't all just flat. You can see them from here. They have different rotation, just rotating in one direction. And then this guy is just fixing the rotation. Let's see what we're doing here, and we're gonna fix that later. For now, let's see, where are our copies here. So they're going backwards right now. You can see they're going backwards, but they are working. But it's okay that they are backwards, because what we want to do now is actually make them rotate as they go with the particle like that. Right now they're just kind of not doing the correct thing. They kind of are. Yeah, they kind of are. So they just, we want to go and give them some rotation. Okay, so what we need to do with these arrows, we're just gonna correct their rotation so they're pointing in the right direction. This is not the attribute, sorry, it should be this. So there we go, they are not now pointing in the right direction. They're flying and they fall and they stick to the ground. Really cool, right? Cool. All right, but what we're gonna do is actually not use that kind of a rotation here. Let's go here in the pop net. I'm gonna put a pop spin, so not every arrow is in the same exact orientation, right? We can show this guy to show the particles direction. You can see each particle should have an axis, but it's pretty small because we are in a pretty huge scene. All right, you can see there it is. There you can see the axis for the particles. All right, so what we want is actually in the pop spin, make it relative to the particle. You can see now, you can see them better. And we want to spin the particles in the x-axis. You can see the x-axis is here, and the arrow is going to be in this direction, so we want to rotate them in the x-axis so they go up and then go down. So let's say we're going to put a spin of 1. Now you can see they are going and doing that. You can see the z-axis is the front axis always, and they are going and then they fall and they do that. But again, we don't want them to be all the same, so we're going to put a little expression here. So don't be afraid of expressions. I use really simple expressions. So we're going to just say the spin speed, which is this attribute here. I know the name because it's here. You can see the parameter name is there. So we're going to say that this attribute is going to be equal to, again, just an expression of randomness. Rand. We're going to use again $ID because that's important with particles. And then let's just stop this. Then we're just going to put this is going to give us values from 0 1, but we want these values to go in a different put them in a different range. So we're going to put the fit 0 1 expression. We're going to wrap this and say this is the value we're going to fit to a new range, and the range is going to be from 8 to 12, which is something that I figured out by doing this. So now if we go back and see this, particles are going to be going like that, and each one is going to have a different rotation. You can see they are going in different directions. They are not every particle is not the same. They're just rotated a little bit differently. So now if we go back to the arrow so we can see this better, you can see now here the arrows gonna go. Now the rotation is wrong, but you can see they are all falling there and they have a different rotation. So let's reset this value and we should be rotated like this when we start, and go like that. Arrows are coming at us now and they are all having a different rotation, and they fall into the ground and they stop, and that looks pretty cool. You can see every arrow has a different rotation as it should, and looks pretty cool. It's sticking to the terrain. You can see we have the terrain, they are sticking to the terrain. Each one has a different height and all that stuff, and we didn't have to set that. If you want to control that, you can give more controls, but since we reduce the terrain, the error of collision becomes a little bit greater, and that gives it that kind of variance there. Alright, so after this, the only other thing I did is just added some other debris. You can see this is my other simulation. I added extra debris here, which is just can see when the arrows collide into the ground, I created some dust. So if you get this file, you can see how I did that, and I did that in the simulation here. I split the particles here and emitted some particles in the ground. We already seen that in other training, so in other videos. So if you know already how to do that, you can do that. And then I just deleted the two parts. I copied particles, the arrows to the particles here, and other particles to the debris. Render them separately. You can see here's the debris, and the arrows are over here. I'm gonna skip that. I'm gonna delete that one. I'm gonna hide this one. You see there's the debris. You can see that's the debris there on the ground, and this got disconnected. So when the arrows hit, it emits a little bit of dirt there in the ground. Alright guys, so this was a little bit long, but the effect is pretty simple, and I hope that you guys get a lot of use for this. Using particles to instance geometry is a really nice way to give complexity to your shots, but I wanted to give you the tools to not have all the arrows looking the same. Alright guys, so this is Varomix, and let's keep learning together. I will see you in the next one. Cheers!